Hello, AP Stat students. Mr. Hazelhorst coming to you live from room A08 today. I hope you're having a fantastic day. We want to take our final video of Chapter 2 and talk about the idea of assessing normality. Okay? Now, we need to understand a big thought for the day. Many of the statistical procedures that we're going to use in the future are based on the assumption that a population is approximately normally distributed. Now, if you think back to all the problems that we've been doing within your textbook, every time we do a problem, we see that phrase in the problem, approximately normal, right? Well, the reality of statistics is life is not written in a textbook. If you were out collecting data on your own, whether it would be in a research lab or if you were polling people and you wanted to apply the concept of a normal distribution, you can't look up your problem in a giant world textbook and say, is this approximately normal, all right? As a statistician, you would need to determine that normality for yourself. And so because of this, we need a strategy that we can use to assess the normality of data. And that's what we want to jump into today. The good news is it's actually a relatively simple thing to do. There are a lot of techniques that we can utilize to assess normality, and we kind of want to walk through some of those, all right? And so let's begin with a set of data. All right, those numbers are kind of small, but it's really not too critical what they are, or exactly what they are. But they're representing the usable capacity in cubic feet of 36 side-by-side refrigerators. And I have these data in order, right? So our smallest refrigerator is 12.9 cubic feet. Our largest refrigerator is 18.4 cubic feet. That's kind of like the mini fridge in my bedroom where I keep all my midnight snacks. Anyway, though, we need a way to determine, is this data normal? All right, if we just look at the numbers as they're listed out, that's really not very helpful for us to identify anything. So there's a couple of methods that we can utilize. One is we can look at the summary statistics. All right, so if you were to take this data and punch it into the list of your calculator and run the one variable statistics, what you would find is that the mean is 15.825, the standard deviation is 1.217, and the median is 15.9. Now, what we can take from this is there's a good chance that this data is symmetrical because the mean and the median are relatively very close together, okay? Now, the one thing that we still need to know with regards to the normal distribution is a bell-shaped, okay? Now, if we take what we learned the other day in class, we know a very important fact about the normal distribution. We know our 68, 95, 99.7 rule, okay? And so we could apply that here. We could just do a simple count, right? Like we could take our mean and our standard deviation and we could create a range of values that are within one standard deviation of the mean and count up how many values are in there. All right, so if we do that here, here's your numbers that fall within one standard deviation of the mean. One standard deviation of the mean would cover the range 14.608 to 17.042. And so we take all of those numbers that fall within that range, and we see that 24 out of the 36 pieces of data, which accounts for 66.7%, fall within one standard deviation mean. So that's pretty close to our 68% rule. All right, now let's see if the other rules hold up as well. So if we look within two standard deviations of the mean, all right, that's going to cover data values from 13.391 to 18.259. And we can see that 34 out of 36 of them fall within that range. And so looking pretty good there, right? 94.4%, so really close to that 95%. And then the number of values that fall within three standard deviations of the mean, well, that hits 100%, okay? And so based on the 68, 95, 99.7 rule, this data does appear to be normal, okay? Again, the mean and median are close, so we can look at these distributions from a numerical standpoint. We can also look at them from a graphical standpoint. It would have been very easy for us to take this data and create a histogram of it, okay? And if we create a histogram, we can see that, it's approximately symmetrical. It's a unimodal graph, and again, we're seeing characteristics that yes, this distribution of data does appear to be normal, okay? Now, these are a couple of methods that we can utilize to analyze the normality of data, but these kind of take a little bit of time, right? And imagine if we had a huge set of numbers. Imagine that we were dealing with 500 numbers, right? To take the time to figure out how many of them fall within 1 standard deviation of the mean and 2 standard deviations of the mean and 3 standard deviations of the mean, well, that would take us a long time. And the good news is we have a quicker method that we can utilize to analyze the normality of the set of data. And that's what we refer to as a normal probability plot, which the normal probability plot is just simply a graph that is used to assess the normality of data by plotting points. And those points are going to be represented by the data value on the x-axis, all right? And then calculating each individual data value z-score, all right? So think of our standard score, right? The data value minus the mean divided by the standard deviation, or z-score, okay? And what that will create is a graph that looks like this. So this is the normal probability plot that is associated with our previous problem, okay? And we said before, right, that data was approximately normal, and our normal probability plot supports that decision. And here's why. What do we want to see when we look at a normal probability plot? Well, we want to see that all of the points of the data lie close to a straight line. Right? If we look at a normal probability plot and we see a relatively linear form, that indicates to us that yes, this set of data follows a normal distribution. It would be appropriate for us to utilize a normal distribution in analyzing this set of data. Okay? Now notice that this is not a perfectly straight line, right? But we're also recognizing that our data was not perfectly normal. And we don't need it to be perfectly normal. We need it to be approximately normal, okay? Now, the great news about a normal probability plot is that these can be created on your graphing calculator. And when we gather back together as a class to go over this material, we're going to take some data that you submit for us, and we're going to analyze a whole bunch of different quantitative scenarios to determine if those variables would be normal. All right, so we will walk through in class how to use your graphing calculator to create a normal probability plot, and it's a very simple thing to do, okay? Now, if what we want to see is a straight line, we also need to ask ourselves our question, what do we not want to see in a normal probability plot, okay? Well, ultimately, what we're looking for are systematic deviations from a straight line. That's going to indicate to us that our distribution isn't what we refer to as a non-normal distribution. Maybe it's bimodal, maybe it's skewed, because again, our normal distribution needs to be symmetrical and bell-shaped, unimodal. Now, those systematic deviations are generally going to look like a curve in their set of data. All right, outliers are also going to show up in our normal probability plot as points that are far from the overall pattern of the plot. Now, one thing we need to point out, if we look at this normal probability plot, you might see this gap here between our first and second point, okay? And we talked about with histograms, those gaps kind of point towards potential outliers. Now, in a normal probability plot, we're not worried about gaps. What we're worried about is deviations from the pattern. If I look at this point, yeah, it's separated out, right? There's a gap between point 1 and point 2, but all the points follow the overall pattern of that linearity of the data, okay? So let's take a look at a couple of examples of normal probability plots, both good and bad. So when we're interpreting a normal probability plot, all right, we want to, again, look for shapes that show clear departures from normality, all right? And we have to be careful not to overreact to what your textbook refers to as minor wiggles in the plot, right? So here we have 4 examples of normal probability plots, right? These two on the left side represent data that would be considered normal. Now, if we look at this top graph, you can see, you know, it's really not a straight line. It's more of a squiggly line. But again, we're just trying to show that the data is approximately normal. So we don't need a perfectly straight line. Okay, again, we can ignore those minor wiggles. All right, and the general pattern of that data is that it is approximately linear. All right, same thing we see in this second set of data. While we've got some gaps in there, right, those gaps don't worry us. because again, all the points follow the overall pattern of a line. Okay. Now our two graphs on the right represent normal probability plots that would be representative of non-normal data. All right, particularly in these two cases, they're showing strong skews. All right, so if we take a look here in the graph towards the top, we can see that there's a definite curved pattern, all right, that falls within that normal probability plot. You know, a line would not really represent this very well at all. Okay, so that's going to tell us, you know what, pretty good chance here this is not a normal distribution. We have some sort of skew going on. Now, the second graph, right, if we kind of ignore these 2 points on the right, appear to possibly be a little bit linear here, right? But again, we've got these two strong, and these 2 points would be outliers. Okay. Now we see big gaps, but what really makes them an outlier is that they don't follow the pattern of the data, right? The pattern of my data represents this very steep line, right? Very steep line. But this point out here does not follow that line, it's a pattern at all. All right. So those are just a little basic information about the normal probability plot. So I want to thank you for your time of listening today. I hope you took some good notes. All right, again, just a reminder, you get to use those on a quiz that we'll have coming up here soon. But I also want to ask you to do 2 things today. One, complete the form like you always do. But there is also a link to a data collection survey that is posted below the Chapter 2.2c video and below the form that you normally fill out. And I want to collect some data about our AP Stat students that we can use to analyze different sets of data for whether or not they're normal. Okay, so if you would take a few minutes, it won't take you very long. It's completely anonymous. All right, I'm going to ask you some questions like height and weight and shoe size. And again, you're not going to have to put your name on it at all, so you don't have to worry about us figuring out how skinny you really are or how big your feet are. Just go ahead and input that data in. We just need some numbers that we can utilize to, again, assess normality so that we can practice this in class. So I hope you have a fantastic day, and we will see you soon.